The big five equations, you guys. This is an exciting moment. When we go through these equations, there's a whole bunch of equations, and they're all solving for similar quantities. How do I say this? There's five variables, and they all have those five variables in them, but in different sort of whatever representations. So here's what I mean. Here's kind of the zero one. This one is just kind of an average. If you've got two different velocities and you add them and divide by two, you're just finding an average. So I don't consider that one of the big five. That's like the minor equation. We got this guy though. Here's what we've got. We've got V2, V1, A, and T. If we go to the next equation, notice there's no A in number 2, but there is a D in number 2. In number 3, we've got D, V1, A, and T, but no V2. Number 4, number 5. What we've got is we've got five variables. So there's five variables that we're solving for, again, other than this average one, okay? So other than sort of the equation 0 here. But we have five variables. What we've got is V1, V2, acceleration, time, displacement. Okay, so these things are all vectors other than time. These things are all vectors. These five equations all eliminate one of these variables. So if you look at equation number 1 over here, it has no D in it. Okay, so we've rearranged the equation, or we've come up with an equation that eliminates D. Number 2 has D, but you'll notice it has no A. Number 3 has no V2. Number 4 has no time. Number 5 has no V1. So every one of the equations has kind of eliminated one of those five variables. So there's a lot of equations, it's a lot of variables, they're all on your equation sheet. So you don't have to memorize them or anything like that. Even when we have regular school, we don't have to memorize these. We give them to you on an equation sheet. The way that they're set up though, excuse me, the way that they're set up is if I give you 3 pieces of information, you can solve for number 4. It doesn't have to be the ones that I've underlined there. It could be that I give you these 3 pieces of information and you solve for number 4. But at any rate, I give you 3, excuse me, you solve for number 4. Okay, so that's how all these equations are set up. You got to look for, whenever you read a question, you got to look for 3 pieces of information that you know, sub those in, and then you can solve for whatever the 4th one is. A couple things. When I go through these, sometimes kids ask for, what are some steps? How do I solve these word problems? So we're going to see a couple word problems in a sec, but these are your typical math problems, right? There's a bunch of words and some numbers given in there, and they ask you to find something. So I will encourage you to try to follow these steps. Sometimes you got to, modify a little bit, but in general, these are the steps that you need to follow. So first of all, write down what you know. People often call this like your given information. In there, you can also identify what is unknown. Okay, so identify your kind of given information, identify your unknowns. Draw a little picture. I don't care if you're a good artist or not, but just draw me some kind of little picture that describes what's going on. Really, this is to help you figure out what's going on. We've done this a little bit already. As soon as we started seeing vectors, make sure that you pick a positive direction and kind of stick with that throughout your question. We're going to choose an equation. Okay, so here's the E. This is guess method that I'm kind of building up here, right? Then we're going to sub in and we're going to solve, and there's your S's. So when you hear people say guess method, there's the S's from here. Guess method, there's other acronyms like this, but guess method is kind of write down what you know, identify what is unknown, what it is you're looking for, choose an equation, then you're going to sub into that equation, you're going to solve. All right, let's try to keep this video shorter, so because there's going to be lots of questions to solve. Astronaut Hala is landing on Mars and experiences an acceleration of 49 meters per second squared over 10 seconds before coming to rest. What was her initial velocity? That's V1. So there's our unknown, first unknown. What was her average velocity? Okay, so that's the second thing we're looking for. We're given some numbers up here. Okay, so we're given like 49 meters per second squared, 10 seconds. What are these numbers? Let's identify what these things are, but let's also kind of think of her spaceship coming down. So I don't know what her spaceship looks like here. Kind of looks like a top hat or something. Here's her spaceship. Here's the legs, and here's some flames. We can pull out some orange flames. Here she comes down. She's landing on the surface of Mars. Of course, we know Mars is red, so here's the surface of Mars. As she descends towards the surface of Mars, it says that she's eventually coming to rest. What that means is right down here, just before she impacts the ground, her V2 goes to 0. This is kind of like something to watch for, but when it says her ship comes to rest, that's kind of a tip-off that this is V2. If it's rest, that means it's 0. So V2 is equal to 0. 10 seconds, that's probably a pretty easy one, right? The time that it takes, the elapsed time or the change in time. Her watch is going to change by 10 seconds during this whole journey. This thing right here, I mean, it tells us that it's acceleration, but even if it didn't say the word acceleration, we should know from those units that acceleration is 49 meters per second squared. I want you to think for 1 sec before I give you the answer. What direction is this acceleration? Remember, acceleration is a vector. I want to fill in what direction this is. What direction is her ship accelerating? Her ship is going to be accelerating up this way. Okay, her velocity is down this way. She does not want to speed up and crash into the planet. She wants to slow down and gently land on the planet. Okay, so her acceleration is upwards, but just notice that her velocity is down the entire time. Okay, so that's something to notice. Let's see if we can solve these. So for part A, here's my given information, right? I know acceleration, I know time, I know this velocity down here, over here, I guess. We know all these things. What we're looking for is V1. We want to choose an equation that has those 4 variables in it. So V2 equals V1 plus AT. I often write it without all the vector signs and the deltas and stuff like that, just to keep it simple. You're welcome to put them in. I don't need to see them until your final answer anyways. I'm going to choose upwards as my positive direction. So when I sub numbers in, like acceleration, it's going to go in as a positive. Okay, so V2 is 0. V1, that's unknown. Acceleration, though, we know is 49. And I said up is positive. This thing is up. It goes in as a positive. Time is 10 seconds. We multiply those things together. 490. Whoops, this should be plus. We take it to the other side. What we get is V1 is negative 490 meters per second. Remember, our first answer is always in whatever we chose as the positive direction. That's up. What that means is, and we should do sig digs here, I'll say V1 is positive 4.9 times 10 to the 2 meters per second. This is down. Okay, so just as a reminder, we can kind of stick our vector sign on this. Just as a reminder, if you say your first answer is negative up, we'll change that to positive down. Okay, we're running out of room here, so I'm going to see if I'm just going to make a little bit of room right over here. Just remember V2 was 0. Let's change to blue here. V2 was still 0, so that's at the bottom. I'll write it here. V2 is 0. And I'm going to see if I can squeeze B right in here. What was her what was her average velocity? We saw that equation just a second ago. V average is V1 plus V2 divided by 2. We're looking for this V average. V1, I'm going to stick with up being positive. Okay, so I'm going to sub in this value right over here. Whoops, negative 490. V2 is 0, divided by 2. Her average velocity then, 245. So negative 245 meters per second. Again, first answer in the positive direction. Therefore, what we could say is V average is approximately, I guess that would be 2.5 if we round for sig digs. 2.5 times 10 to the 2 meters per second. And again, don't forget, negative up, positive down. And we can stick our vector sign on there now. There's our average velocity, about 250 meters per second down. Another question. Let's try this one out. And if you're feeling confident, you can pause the video and kind of work ahead of me for a sec, see if you can identify the variables, try to solve it if you want, and then unpause and I'll finish up solving it. Yeah, let's use blue. That's a happy color. Okay, we're given a bunch of information again. So we've got this piece of information, this piece of information. We see this word stop over here. Okay, so let's do the easy one first. If you see meters per second squared as your unit, that's got to be an acceleration. Okay, so 3.0 meters per second squared. Keep in mind, this thing is slowing down. This Hummer, this big truck, is slowing down. That means you're accelerating kind of backwards compared to your forwards motion. Okay, so then we've got this first number here, 10 meters per second. That's got to be one of the velocities. The question is which one? Is this V1 or V2? But I'll just keep in mind here, this is forward. So if they don't give you directions, you can just say whatever direction I'm moving here, I'm going to call that forward. This one then, because I'm slowing down, must be backwards. And it says something here that the truck or the Hummer or whatever is going this fast. That's an indication that it's V1, because what they're saying is later on, this thing is going to stop. If it's going to stop, that's V2, that's 0. And the question is, what is the displacement? Okay, so here's V1, here's V2. I'll put all my vector signs in. If you wanted to picture what's going on, a Hummer is basically a big box on wheels. So here's the Hummer. It is going 10 meters per second this way, but it is slowing down. Okay, so its acceleration is back this way, which means it's going to slow down and stop. Eventually it stops over here. So V2 is 0. I'll put some zoomy lines here to show how fast it's going, and by the time it comes to the right over here, V2 is 0, it's going to stop. What we're looking for is displacement. Let's say from here, so the front of the car to the front of the car, what we're looking for is, what is this? Okay, that's what we're trying to find. If I then go through to solve this thing, we're going to choose an equation. So here's our kind of our givens. Here's our unknown. Sort of step 3, I guess it is. We're going to solve this thing. So V2 squared, V1 squared, plus 2AD. V2 is 0. V1 is 10. I'm choosing positive, my positive direction to be that forwards direction. Okay, so the 10 is forwards. My acceleration then, because it's backwards, that's going to go in as a negative number times d. Okay, so I didn't put the vector signs, but these things are all vectors. 2 times negative 3 is going to give me negative 6d. I'm going to take that to the other side. That's going to become positive 6d, and 10 squared is 100. Okay, so this thing right here became that thing right there. That line is good because then I'll divide both sides by 6. It can cancel out over here. What we're going to get is we're really solving for a displacement here. And let's see, 100 over 6. I did that somewhere. 100 over 6, yeah, 16.67 meters. That is in the positive direction, so forward. And then let's just come over here. Let's do our sig digs. We've got 2 sig digs as all of our numbers. So I would say displacement approximately 17 meters forward. That's a pretty quick stop. Last one. Same idea, you guys, as we do these. Navya has a constant acceleration. So again, let's just write this down. Acceleration 4 meters per second squared. If she starts from rest, okay, so that's an indication that this is V1 is 0. How long does it take her to travel 100 meters? There's a displacement, 100 meters. Whatever our forwards direction is, so this acceleration, it sounds to me like we're starting from rest and we're speeding up. Okay, so that acceleration must be forwards. Our displacement then must be forwards as well. And again, I'll draw Navya as a box. Here she is. She starts from rest. She's going to start accelerating and she's going to get going this way. And then the question is, how much time? So how much time does it take her to travel 100 meters as she does this accelerating. So we don't know how fast she's going over here, but she has traveled this like 100 meters in here. Okay, so the question is how long? That's time. Same idea with all these questions. We're going to pull out an equation that has those variables in it. What you could look at here is if you think of what are the 5 variables, there's 4 out of the 5. The 5th one is V2. V2 is the one I don't care about. So sometimes people look at this equation, they say, I'm going to pull out the one that eliminates V2. Okay, so this equation, you could say it eliminates V2 out of it. That's why I'm choosing this equation. Sometimes that helps people. If it doesn't help you, don't worry about it. But if it helps you to kind of think of like what got eliminated, sometimes that kind of helps people as they go through this. We're going to stick with, again, this forwards direction being our positive direction. So that means displacement is forwards. V1 is just 0. Remember, 0 times anything is just 0, so this whole thing goes away. Acceleration is 4. T, that's what we're looking for. Don't forget it's squared. We can divide both sides by 2. We're going to take the square root of that, and we are going to get 7.07. And again, for sig digs, we're talking about 2 sig digs. This one, we're always going to pretend there's a decimal at the end, just as a reminder. Okay, so we're going to take this as 3 sig digs, 2 sig digs. We want the least number of sig digs. So it's approximately 7.1 seconds. There it is. These questions aren't too hard, you guys. They will get hard, I promise, but to start with, they're not too hard. But what we're doing is, I think it's really important, just make sure you do this. Identify what you know and what you don't know. That'll help you decide what equation. Don't forget to choose your positive direction. Again, that's really important. You'll get wrong answers if you don't. And that's it. You can feel like you graduated now if you want to listen to Pomp and Circumstance down here. You can feel like you're super important, and try some homework.